1, 2.
Let's go.
Can they hear me? Can you hear me? Okay, awesome. All right. Hello, everyone. Welcome to our talk on web isolation. Man, it was such an inspiring keynote.
It was amazing.
Like, it will be very hard to follow, you know?
We basically should sit down now.
Yeah, we should run away, right? All right, so I'm Pedro Fortuna. I'm co-founder and CTO of JScrambler. I also helped start the new OWASP Lisboa chapter. Basically, we had our first meetup this week. I hope the other chapter leaders are somewhere in there. But basically, I've been working in security for as far as I can remember.
My name is Jaz Spear. Most people call me Jaz. You should too. The VIR stands for virtualization, I think. No response at all, huh? All right. I've probably been working in security almost as long as Pedro can remember.
Okay, so time for a little story.
Pedro, it's 10 a.m. I'm barely a coffee in. Are we going to do this?
Yep, we need to push through,
Okay.
like people are waiting. So it's a story about a ship. Some of you may recognize this ship. It's the Titanic. And it was built in Belfast, in their famous shipyard, which I was lucky enough to visit during the OWASP AppSec EU 2017, I guess. But we want to talk about how it was built. Many people do not know this, but when it was built, it was bleeding edge in many ways. So the bottom of the ship was split into 16 watertight compartments. So it was made such it could withstand some damage without compromising the whole ship. It could, I think, up to 2 adjacent compartments could be completely flooded, which back then it was like the worst situation they could imagine. And that's mainly the reason why they deemed the Titanic to be unsinkable. So they made a great fuss about it. But depending on the exact location of the damage, it could actually withstand up to 4 adjacent watertight compartments completely flooded without sinking the ship. So we all know how this story ended. When the Titanic hit an iceberg, the 6 forward compartments were completely flooded and the Titanic sunk. So even though the story didn't end well, compartmentation was a great idea, and it is still used in ship design to this day. So the main idea is that if a section is damaged, it doesn't compromise other parts of the system. The problem with the Titanic is that its implementation was flawed, but we'll tell you more about that later.
This is a cliffhanger at this point?
Yeah, I guess so.
All right. So
let's talk about web isolation then. A little bit of history before we start.
Okay.
So the first real attempt at web isolation was introduced by the same origin policy to restrict how 2 different origins interact with each other. But restrict how if actually we can embed a third party, like a cross-origin script from the third-party origin directly to a web page, and this script will actually have the same level of privilege as any other script, like same origin scripts. So where is the same origin restricting anything here? So it turns out that embedding is permitted. What is restricted is writing to or reading raw data from cross-origin domains. So the reality is that the same origin policy is complex and has lots of exceptions, and to this day, many developers don't fully understand how it works, which is frequently a source of security issues. 2 years later, they have given us like iframes, okay, with which we can isolate 2 documents or scripts running on the same web page. But the problem is that people soon enough started to look for ways to have these two different origins communicating with itself, like coming with hacks and creative hacks, basically. And we only threw the towel 13 years later and made it official by introducing the web messaging API, with which two different origins can communicate using a post message, basically. But not every problem went away. So, for instance, iframes still had a lot of power. An iframe document can navigate to the top window, among other things. So we had to solve that problem too. And 13 years later, we got iframe sandboxing, with which we could restrict very heavily what an iframe is allowed to do. But the problem is that at the same time, they have given us these configuration attributes that allow us to relax the iframe, sandbox iframe. So it's like they given like the power and then they take it away. And people, obviously, they're going to use these things to relax the sandboxing. About the same time, we got Content Security Policy version 1, with which you can do domain-based allow listing, which was later found to be completely broken, and you can read all about it in the paper that you can see on the right. Plus, it's very hard to maintain. So later on, versions 2 and 3, they fixed these problems, but they are not straightforward to set up. So I would say that like the main critique that we have on CSP is that it is kind of binary. Like either you fully allow a script to run or you fully block it. There's no middle ground. So basically, if it was more granular, it could be more useful for sure. And this basically concludes that the problem with these isolation mechanisms is that they lack granularity. The boxes of isolation that they provide are not configurable. So there was never one isolation feature with which you could do like full isolation of a web app. So it has been more about stitching together all of these isolation features and hopefully to cover as much ground as you want. So this is both complex and error-prone. So inevitably, you will leave holes or blind spots. For instance, JSON-P and cores are good examples. So if they were configurable and granular, maybe people wouldn't like had the need to try to find ways to relax these features or to poke holes on them. And here you can see the timeline where these features were introduced. You'll notice a huge gap between '97 and 2009, which you really have to wonder what the browser people were doing back then.
We needed our pacemakers configured at a higher pace, I think. All right, so what Pedro has been talking about is a large variety of different features that browsers give us. The thing that we are trying to get to is isolation. What we are trying to build is the ability to isolate different scripts and their actions. But what we have is a variety of security features that the browsers have implemented almost reactively as different attacks arose. The question is, can we use those features to put together a more solid, a more systematic way of building isolation? And I think that the answer is yes, and you shouldn't just believe me. The community, you and I, we all have been building essentially a mechanism for doing web isolation on top of the browser features that we have. I'm going to describe two different primary mechanisms that we use in order to implement web isolation. And the two techniques that mostly we use are virtualization and transformation. Now, there's 3 projects that I've randomly chosen to put on this graph, but most mechanisms for web isolation end up falling somewhere on this graph. You have virtualization, where what you do is you virtualize, you replace the versions that are provided by the browser with our own attenuated version. If you see something that is dangerous, you replace it with something that is less dangerous or easier to control. And then you have transformation, where you're simply changing the source code so that you remove the bad things from your application. So we have way off on the top right, we have a project called Google Kaha, which was an open source sandboxing project with which I was intimately involved, which uses both a combination of virtualization and transformation to achieve this sandboxing. There was another open source project called JSReg, which uses mostly transformation in order to achieve the same kind of effect. And then we have JScrambler, with which Pedro is intimately familiar, which uses more virtualization. But essentially what we have we have 2 tricks in our toolbox to use to build isolation, which is what we are trying to get to. Now, I'm going to talk first about virtualization. What is virtualization? Well, I call it virtualization, but we all already know this as polyfills, right? What is a polyfill? You have features that are provided by the browser, or sometimes you don't have a feature that is provided by the browser. You implement it using other mechanisms that are available. When you use virtualization for security, even in cases where the browser provides some particular capability, you end up replacing it. So for example, if you have date, this is the real date object provided by the browser, you might provide a virtualized version. Well, date, unless you care about timing attacks, you can just provide the original date object directly to third-party code. Another case we saw in the keynote, a browser, I'm going to name the browser. Am I going to name the browser? IE6, which uses ActiveX. ActiveX was overly powerful. If a third party had access to ActiveX, there was a huge number of things that they were able to do, and maybe you don't want to provide access to ActiveX. So you never provide this to third-party code. But you can also do a thing called attenuation, where IE6 also did not provide a compatible XHR object, but ActiveX was able to implement XHR. And so what you can do is implement a version of XHR on top of ActiveX, and then via the power of virtualization, you hand only a version of XHR to third-party code. And you can even provide a version of XHR that only connects to particular proxies, connects to only particular third-party sites. And therefore, you're sort of controlling exactly how much power this third-party code gets. Similarly, you can virtualize the DOM, you can virtualize access to location, you can virtualize access to inner HTML, et cetera. And you build up this way of controlling not whether a script executes or not, but how much power the script has when it is executing. So that's virtualization for control. There is another version where we use transformation. Now, this is easily my most favorite slide. Pedro gets a little nervous when I get very excited about this. But essentially, this is the mechanism by which almost every language-based sandboxing control works. On the left-hand side, my right-hand side, what you have is the variety of functions that you're going to call. So you have alert, which is like a system call for the browser, right? These are functions that are provided externally. You have strings, which are types. You have function types and array types. You have a variety of primitive types which are provided by the browser. What you can do is transform this and rewrite it so that each one of those functions, types, and primitive objects are instead accessed only as a result of an argument to a function. So this is a very simple kind of transformation, but if you think about this, this means that the caller of this function controls everything that is happening inside this function. Every call goes via, is controlled by the caller. And this basic primitive allows you to essentially sandbox large pieces of JavaScript. Now, I know those of you that are familiar with JavaScript are like, Jazz, look, there's all this eval that allows you to break out of the sandbox, and there's ways of walking up the constructor chain, there's ways of walking up the prototype chain, and you're absolutely right. But the basic idea is this one, and this is really, I mean, it's a basic mechanism of sandboxing, and it fits on a single slide. And I think that that's one of the reasons why its power and simplicity together mean it is the basic building block of what we're going to end up building.
You see how he gets excited about this, too.
You can come talk to me after this. I can talk about this for hours. Can we do this for HTML? And the answer is obviously yes. It's actually even simpler for HTML because HTML is a much simpler language. And so, you can do a series of rewrites for HTML. On this side, you have styles, and for CSS, it's even easier. If you prefix every CSS rule with, let's say, in this case, .gadget123, that means that the scope of what is affected is now limited to only the children of an element that has that particular class. Overall, what is happening here? We're not allowing or blocking HTML. We're not blocking or allowing CSS. We're not blocking or allowing JavaScript. What we're doing is controlling how much access any particular part of the code has access to. And then this is a very powerful general technique, right? You don't just need it for visibility. You can also use it, you don't just use it for control. You can also use it for visibility. You can transform each one of these functions such that all of the access goes via one function that you control, and it can do a variety of things. In yesterday's talk, I think JB talked about how valuable observability is when you're doing pen testing. Observability, or visibility as we end up calling it, is very critical because sooner or later, functions fail. Now, this room is filled with clever hackers, and sooner or later, the foolish people who are standing on stage, who are building sandboxes, our sandboxes end up failing. What is critical is not to build sandboxes that remain absolutely robust, but build sandboxes such that when the sandboxes fail, you get visibility. You come to find out that the attackers are in, and so that you can end up responding, and virtualization ends up giving you the same kind of control. In general, what is happening is there's some general design principles that we are using in order to build these. Actually, in yesterday's keynote, there was a slide that Alyssa presented, which, as I go through the three principles, mirror the principles that she was talking about as well. So there's going to be three principles. It's visibility, ease of use, and control. Compartment size. Let's say we are building a ship. One of the problems in the Titanic was how small the unit of isolation is. If you think about all of the controls that we have generally built, the controls are either the size of the host, or the size of a domain, or the size of a particular path in the domain, or the size of a particular file, or the size of a particular function, or in the case of JScrambler, specific actions, right?
And you had the other example of CSP, like you either allow the whole script or you block it at all. Like you cannot have a smaller box for that.
Exactly. So the smaller the size of the compartment, the more control you have over exactly how much functionality you are allowing. Now, there's a counter to this, which is the smaller the size of each one of these compartments, the larger the number of, the larger the complexity of the configuration is going to be. But we can counter that by building additional tools that make it easier to configure these fine-grained compartments. The second thing, if we go back to the story of the Titanic that we need to keep in our mind, is the strength of the isolation material. Now, I'm stretching the analogy a little bit, but essentially, when we build mechanisms for isolation, like iframes, like CSP, if they are cut in the wrong direction, we end up having to drill holes through them. And like any structure, if you start out with a solid structure, but you continuously drill holes, you start out with a ship, but you build little rooms into them so that they are able to do what the functionality you require is, then you end up weakening the structure. In order to maintain the strength of the isolation material, in order to maintain the strength of the isolation mechanisms that we have to align with how developers end up using the software. Most of the mechanisms that browsers provide were built for Web 1.0, which is a very different way in which applications were being built than the way in which we build applications today. And sooner or later, developers come up with ways of working around the isolation mechanisms that we provide. And the third one is, of course, visibility and user-friendliness. This is this is a point that I was making earlier. What you don't know may end up really hurting you. You need to understand the nature of the attacks in order to understand exactly how attackers and your users are responding to the mechanisms that you're building. I end up sometimes saying to people, developers are people too, which is sometimes not obvious to us. The user-friendliness of the tools that we build is a very critical part of enticing developers to use our tools and to use the tools in a way that enhances the security of the application rather than being something that they need to work against.
And we are back to our cliffhanger. So basically, we told you that the Titanic implementation was flawed. And this is kind of a summary of some of the things we already said. Like, for the Titanic, the compartments were too big. Okay, so they would need to have smaller compartments in order to be able to withstand more compartments being completely flooded. Because when you flood a compartment, you flood the whole compartment. If the hit is more precise, maybe the size of the thing that you're flooding is smaller, and that makes you more resilient. The materials, so obviously it wasn't strong enough because it hit an iceberg, so if it was made of stronger materials, maybe it could withstand the hit. The damage model had the wrong assumptions, or in other words, basically the threat model was wrong, was flawed. And last but not least, the lack of visibility, because of obvious reasons. If someone had spotted the iceberg in time, they would not collide with the iceberg. So visibility and analytics, which are an interpretation of what you're seeing, are very critical for avoiding these set of problems. So now, time for some demos. And to understand the challenges, we first need to understand what we have been doing wrong. So as for browser security, isolation, native security isolation features, things have moved slow and erratically. Like I said, we didn't have one feature that could provide the type of isolation and user-friendliness and flexible enough. It has been mostly about stitching together all of these features that we talked about. As for other solutions beyond the browser-native solutions, there are very few solutions out there. Like Google Caja is a good example of a holistic web isolation solution, but sadly it was discontinued, which Jazz, if you don't know, he was the lead of that project back then at Google. Apart from Caja, there's web page integrity, the project that we are doing.
So what does the next 20 years look like? Given where we have come from, what we need is a single, holistic, client-side web solution that covers all of these different angles that we've talked about. What we need is a sort of a broad, coherent plan. And I think that that plan will come together guided by these three principles we've been talking about. Limiting the size and granularity of the compartments that we're building, making sure that each one of these granular boundaries that we build are solid and reliable, and then providing visibility and user-friendliness. So on the one side, making sure that developers find these APIs easy to use, but also have these APIs provide feedback so that as they are being used, not only do we know whether developers are using them well, but we also know when attackers are bypassing them. As we were making this presentation, Pedro and I joked about how do you make a ship that is actually unsinkable, and I think Pedro said you give it wings, and you can take away from that what you want. I wanted to pull an example of a feature that was introduced into browsers that has this particular characteristic, so that you don't walk away going, oh, this is all doomed, I have seen no progress. Shadow Realms was formalized and has made quite a bit of progress in being shipped out to browsers. This is an example of something that I think demonstrates the design features. What a Shadow Realm allows you to do is to create a separate enclave that you're able to interact with, that you're able to insert third-party code into, and then it executes independently of the rest of your code. It has, it's a very tiny little isolation boundary. It has strong foundations. The user-friendliness is an interesting question, but it operates mostly like an eval, but the context is controlled by the caller. That means that developers are going to be able to much more easily roll out the use of things like Shadow Realms. And there are other features like that coming into browsers. Like the same way that WPI provides all of these, I think that other browser features that are going to end up having these kinds of characteristics. How far along are we? Well, large, complex features like web isolation take a long time to build. And they take a long time to bake as well, because one of the things that we want to be able to do is put features into browsers that remain solid, that remain usable, so that the next generation of web applications are not merely secure, but also functional and usable. And characteristics like that take time to bake.
That's all we had for today. Thank you.
We can take questions, and at least for the foreseeable future, unless Twitter goes crazier, we're also contactable.
So thank you, Jazz and Pedro. Any questions? A few more seconds. 3, 2, 1, 0. Okay. Thank you very much, guys.
Thank you.
See you around.
Thank you.
Yeah, I forgot. Nicely done.
Yeah.
Good.